okay, or avocado. The reason we picked Avogadro's number was that we're taking the masses on the periodic table and scaling them up to a measurable amount. Okay, so the example that I may have talked about on, what is today? Tuesday?
Thursday.
The example I may have talked about on Thursday was picking a random element. Let's pick, what's your favorite element, since you asked?
Oh, well, let's see. Probably because it's the one I remember the easiest.
Sure.
Iron. Fe.
Iron. If we take a look at iron in the upper right-hand, where did it go? Upper right-hand corner, we have 26. And at the bottom, we have 55.85. What does the 26 represent? It's the atomic number, which happens to be equal to the number of protons. What is the bottom number from our periodic table? The atomic mass. The units on that are AMUs. Okay. That was derived from the number of protons and neutrons for an individual element. Okay. The issue with that system is our balances don't measure out AMUs. Okay. So if we were to go through and take a look at that mass, say 55.85 AMUs, said another way, this is the mass unit for a single atom. That's our AMU. We wouldn't be able to actually weigh this out reasonably well. So Avogadro's number is there to scale that system up, right, up to a measurable mass. Well, let's do which one? Which one do you want to look at first? The mass, so our unit for mass, or the scaling of atom up through our mole? What's that? The second one. Let's scale our atom up. Right? Let's take atoms, and instead of looking at just a single atom, I'm now going to look at a mole of those atoms. Okay? Well, this is Avogadro's number. Avogadro's number converts or relates those two symbols, and we have 6.022 times 10 to the 23rd atoms is 1 mole. Okay? So why would I pick that? Okay? I could officially pick anything I want, okay? But the power of Avogadro's number, just put them all together, of that number comes in the next step. Okay? That next step is now getting our mass, okay, our arbitrary AMU mass, into a unit system that we know how to measure. What is our unit system for mass that we're used to working with? Grams. Well, what is the conversion factor between grams and AMUs? Most people don't have that memorized, but I see you taking a look at the front.
Do you want to memorize that?
I do not want you to memorize that.
1.66
Times
times 10 to the
negative 24th grams
and over
is 1 AMU. So we have two conversions here. We have one conversion that converts the ultimately useless measurement of AMUs that we can't measure, right, and converts that into a unit system that we're used to working with, grams, a measurable unit or an accepted measurable unit. So that's one conversion. If we did just that conversion, so we're now going to ignore the middle conversion, what number would we end up with? A really, really small number. Something on the order of 10 to the minus 24. Right? Our balance goes to 10 to the minus 3. We're off by 10 to the 20th power, okay, which is larger than our national debt. Okay? So that's a really big difference. So I want to pick a unit system that takes that mass value up to something reasonable that I can work with. Okay? That's why we picked Avogadro. Frick, hell. Avogadro, A-man. We picked that number. Okay? So that's that next conversion. So we're now looking at, come on. Okay, we can go with Avo's number and I'm fine. The one in red is now that conversion factor. Let's get this atom value up to a larger amount. Okay. Why did I pick 6.022 times 10 to the 23rd? Okay. Well, what happens when I run this calculation? Lots of powers of 10. That looks like a complex calculation. We could go through and enter that in the calculator, and I can tell you right now that it's probably going to come out to be roughly 55.85. The units being grams over moles. Why is Avogadro's number such a special value? That takes our atomic mass on the periodic table and now turns it into a molar mass, a gram value that we can actually measure on our balances. That's why we used Avogadro's number. Thank you.
How do you find that out?
Okay. How did they find that out? Through a series of reactions and studying gas. Okay. Gases is the easiest way to find that. And you're right, that is a bit of a challenge. You're dealing with scales that are really, really insane. But that's ultimately where it's coming from. Okay? So that's the power of that number. Once we have that established, we can now use the masses on our periodic table not as atomic masses, but as molar masses, which takes the unit from AMUs into grams per mole. That is now a much more useful system, and it allows me to manipulate almost all the chemical reactions, and for that matter, the rest of this semester and any future semester you may consider in chemistry using moles. That's the power of that number. Okay. After that, it's now just a question of can you use the conversion factor? And what we end up going through and doing is now just a sequence of conversions. Using the dimensional analysis process that we learned before to build us practice with doing the conversions. The hope is that after doing enough different reactions with the unit of mole, you start to actually internalize its meaning so that you can continue to use it and process it further on down the road. Which is a little bit weird. We are making you do calculations before you have a solid grasp on the meaning. The hope is that the calculations reinforce that understanding. Make sense? So, first question, what is the molar mass of copper 2 nitrite? So, our English to chemistry, molar mass. Mass is grams, molar is moles. We combine those two terms, and that is now our grams per mole. Where do we find the information about grams per mole? On the periodic table, which is known as the molar mass. Okay, so I would go through and find the molar mass for each of the elements that went into that compound. What is the molar mass for copper? So we're going to clean that up so I can write. Copper, you said the molar mass was what, 63.55. Not to be completely irritating and annoying, but it's going to be. No.
Oh, grams per mole. Grams per mole.
Grams per mole. So when you asked that question earlier, do you just add up all of the atomic masses on the periodic table? And I said, sort of, not quite right.
Just mathematically.
Mathematically, you're correct, but if you add up the atomic masses, what is your unit? AMUs. Is that what you're being asked to solve for?
No.
No. You're being asked to solve for your grams per mole.
Got it again.
Okay. So that's our copper. What about the nitrogen? 14.01 grams per mole. Oxygen. 16.00 grams per mole. So I just add that up and I would now have the molar mass for copper. Why not?
Because there's multiple
Right. Each of those atoms contributes weight. How many atoms of nitrogen are there?
Two.
Why 4? No. This is a good point. Okay. The 2 inside the parentheses only goes to the oxygen. Okay. The nitrogen is 2 because the 2 outside. So that 14 should be multiplied by 2. The oxygen should be multiplied by 4. We can now add all those up and get our answer, which is something like 150 something. 155 point, I believe it's 557?
Grams.
I got 5.7.
Just 5.7? Okay.
Grams per mole. Come on, man. Sig figs.
Okay, so
It would just be 6.
a couple fun questions come out of this. Sig figs. Okay. Where should we be reporting our sig figs? Okay, I'm hearing 4 what? 4 sig figs because
It starts off with 4.
all the numbers have 4 sig figs, right? Okay, so that means I should have 4 sig figs in my answer. Everybody agree with that?
I agree with that.
No.
No, you don't agree with that. Why do you not agree with that? Because Mike was vigorously shaking his head no.
You do that sometimes, but it's a good trick. Say he does it all.
Why is that not correct? When do you use the fewest number of sig figs? In multiplication and division. To get 155, what did you do? You added those numbers. So it's not the number of sig figs, it's the least precise place, which goes back to our decimal. Each of those values is reported out to the hundredths place, which means your answer needs to get reported to the hundredths place. Okay, so it does get reported as 155.57 grams per mole. Okay. And before you start getting like, I'm not going to volunteer help anymore, please do. We need those discussions. We need to hear about ways that things could go wrong, so we have to be putting that out there. It's useful. I appreciate it. Okay? Is there another thing to consider here? Okay. Kind of, yeah, well, Mike's asking, and of course there's yes, right? Okay. 14.01. Isn't that really just kind of like 14?
Mm-hmm.
Couldn't I just call that 14? Do I want to is a good question. Okay. Based off of your observations of your chemistry instructor, is said chemistry instructor lazy?
Yes.
Yes. On multiple accounts, even better. Thanks. What do you think your chemistry instructor would do for the 14.01? Probably just write 14. Is that correct? No. So your chemistry instructor is wrong. Okay. However, why would I write just 14?
Because it's a
Same reason we don't weigh electrons.
How much does it change my final answer?
By like nothing.
By very small amounts. Okay. In a multiple choice test, would I be able to detect that difference?
Depends.
Probably, particularly because the very lazy instructor is also the one writing said test and thinks it's stupid. I mean, let's pause on that. Doesn't think it's stupid. A good wrong answer to also include in this list. 155.6 would be the complete opposite of a good wrong answer, because that's going through and doing a rounding issue. And we said rounding issues are something that your chemistry instructor thinks are not the nicest and we shouldn't be doing. What's that? 155, I would make the argument is still, actually we could probably slide that. If we said 156, I'd accept that. Why 156? That's not a rounding issue. What is 156? A condensing of the sig figs. Okay, so 156 is a possible one. But I would argue that then that question is a sig fig question. And I don't want to test on sig figs. If I'm going to test on sig figs, it'll be how many significant figures are in this. How do I change put in multiple choice answers that don't test sig figs.
Put the exact same sig fig in all the answers.
Okay, but what are the other answers then?
Oh, sig fig.
That's now a sig fig question. If I change the number of sig figs, it's a sig fig question. How do I provide an answer that gets at a wrong concept that you could have made? 155.56, still getting at a sig fig issue.
You could put 3.
When you were talking about earlier, how many nitrogens there are, someone called out.
We were talking about earlier. Somebody said there were 4 nitrogens. There's a conceptual misstep in multiplying that 2 twice through there. So one of my answers would be nitrogen's mass times 4 and now adding them all up. One of my answers would be not multiplying by 2 or by 4 and just adding the mass of the single atoms. Okay? One of them would be just oxygen by 2, nitrogen by 1. All of those are missteps from interpreting what the formula means back to what molar mass means. Does that make sense? Okay. So what we're doing is pushing away from a sig fig issue because sig figs take away from the chemistry content. What I'm testing on is the chemistry content, not the sig figs. Okay? Kind of make sense? Okay. So, we now have a molar mass for copper 2 nitrite. Did that involve Avogadro's number? Not directly, because Avogadro's number, which by the way, that's twice now I said it correctly. Okay.
Third time?
And of course, now I lose my train of thought. Avogadro's number told us that 63.55, that was 3 times by the way, is grams per mole, not AMUs. So knowing that number did show up indirectly in this system, but we were able to kind of ignore it to just do the math. Make sense?
Unless you're writing it
Okay.
out like before.
Unless we wanted to go through and write all of that out, which I'm going to bet none of you want to do. Okay? So let's try a different question. What is the mass in grams of 0.532 moles of copper 2 nitrite? How did this question become slightly more difficult? Okay, if we go through and take a look at this, I'm being asked to solve for grams, and I am given moles. So I've already made a mistake. Dang, stupid instructors. What is that mistake that I made? Nope.
Looking for grams per mole in the end.
Nope, it says grams. I'm not looking for grams per mole, I'm looking for grams. The left side is just moles. There's no grams in that. Am I looking for grams of water? Grams of elephants? No. That's a stupid question. Why do you ask that? Well, the work doesn't show any of that information. Your work needs to show what you're trying to solve for grams of. What are you trying to solve for grams of? Copper 2 nitrite. As we just learned in the previous class, writing out copper 2 nitrite is going to be a bit tedious. But I'm going to go through for the sake of it and write it out. Oh, God. Which means I got to write it out over here, too. Can't you just, yes, we'll get to the can't you just, which is an important part in this. Okay? And our number, 0.532 moles. Are those units the same? No. So what do we need to do? We need to do a conversion. In that conversion, what needs to happen? Thank you. I need the moles of copper 2 nitrite to show up on the bottom. Why do I want it to show up on the bottom?
Because you cancel out.
So that that unit can cancel with the unit in our previous system. What unit do we want to have shown up on the top? Grams of copper 2 nitrite. Okay, and thank you, Ahmad. This is actually where I was, one of the reasons why I went through with this. Okay, I heard let's use Avogadro's number. Right? That's immediately jumping to the number. Avogadro's number relates what two things? The number of something to a mole of something. This is moles being related to grams. Is that Avogadro's number? Half right, I'll accept that because it has moles in it. Okay? It is entirely wrong numerically.
So what is he?
Okay. So where do we find the relationship between the mass and the moles for a given substance? Okay. Our mass and moles, mass and moles, mass, moles, mass, molar mass. Yeah, where do I find the molar mass? Sorry, I just heard something over there. Where do I find the molar mass? Periodic table. On the periodic table, where does it show copper as a word? It doesn't say it as a word. Where's an extra complication within this question?
You have to find the mass.
You have to know the symbols for copper 2 nitrite to be able to look it up on the periodic table, to then be able to properly place the numerical values into that conversion. If you don't know your nomenclature, you are now dead in the water with this question. So to show your work, what do you do now? Move on to the next question because you've already written as much work as you can provide. Do you get partial credit for this? Absolutely, because you've proven that you understand how those units need to cancel, but you've also proven you don't know your nomenclature. I can't give you full credit, but I can give you a whole lot more credit than if you just gave me that. And for those of you like, there's nothing on the screen. Exactly. When you turn in something with nothing there, I can't give you any points. Put something down, I can now work with you. Believe it or not, I have awarded points for people writing the word something on an exam. With what? No, I won't accept a poop emoji. So, copper 2 nitrite. We should come up with... We need to have a formula for that. Thankfully, copper was Cu, nitrite is NO2. Because it's copper 2, the copper is a +2 charge. Nitrite is a -1. I know I need 2 nitrites. Oh, this looks really familiar. Oh, the conversion factor between grams and moles was exactly what we just solved for. And because you have awesome notes, you can tell me what that conversion factor is. 155.57, wrong. 155.57 grams per mole, still wrong. I said still wrong. 155.57 grams of copper 2 nitrate is
Nitrite.
frick. Nitrite is what? 1 mole of copper 2 nitrite. Okay? We have a numerical representation, we have a unit measure, and we have a substance. What happens if you miss any one of those? You're wrong. Okay? Do not leave those pieces off. You have to show every single one.
From the
Where do we get?
from
I just can't read your numerator number.
it's green.
It is green.
Oh, okay.
155.57. Okay? How are we feeling? Mike, this is stupid. I totally understand it. I agree. Do this next one. Depends on the substance.
Either way.
Grams and 1 mole depends on the substance. That would be the grams being mass, moles, molar mass, which would be found on the periodic table. Depending on what substance I'm looking at, I'm going to get a different molar mass. Right? So, this is a fun little thing to go through and do. Right? I will notice every so often, somebody will come up with this and say that their answer is 10 to the 47.
That's a pretty...
Some number times 10 to the 47. Why are you saying no?
That's looking at your units.
For one thing, that's just doing math, right?
10 to the 47 of
Grams. What's that? Say it couldn't?
No, I could.
No, wouldn't they, are they trying to mix like the 10 to the negative 24? Is that what it was?
There's a simple mathematical mistake made to get this answer. Okay? And we will go through and look at the calculation or the work that would get here. Okay? And that is, yes, wrong. 10 to the 47 makes no sense for this. We're looking at some large number of atoms equaling 10 to the 47th grams.
I can see what they got that.
That's actually saying that each atom weighs more than a gram. Everybody see that? That each atom weighs more than a gram. So, yeah, 10 to the 47, I should have looked this up, is really, really big. I don't even know how heavy our planet is, but that might be planetary size. Okay? So, that's a bit of a calculation misstep. So let's take a look at our conversions. What are we trying to get? Grams of lead. What are we starting with? Our atoms of lead. The number associated with our atoms of lead? 2.55 times 10 to the 23rd. Atoms of lead. Are atoms of lead the same thing as grams of lead? No. Okay, the number is going to vary somehow through this calculation, but the other thing we got to look at is our measurement and the substance. Did the substance change? No. So we've got a nice thing to pay attention to. Our substance isn't changing on us, so that's nice. Will the substance change? As soon as we move into chapter 9, probably on Thursday, yes, the substance will change. Okay. Does the measurement change? Atoms to grams. Yeah, the measurement is changing, so I'm going to have to establish some kind of conversion factor. Oh, come on, reconnect.
Could you just start a...
Ideally, I would find the relationship atoms to grams. Is there a relationship between grams and atoms that you are aware of?
No.
No. There's the atomic mass, our AMUs, which is the mass for a single atom in units of AMUs.
And then grams.
Okay. So we could go through and do that, but then you would have to know how to convert AMUs to grams, which admittedly you could use the front of the exam, but I would make the argument that we could come in a different way.
I did this one.
Okay? And that's fine, it's not wrong. Okay? What else could I convert the atoms to? I don't accept Avogadro's number as an answer. I want the unit moles. What's the conversion factor that relates atoms to moles? Now you can jump in with that. I'm on. Now it's Avogadro's number. Once we've established what unit we're converting to, now we can bring in our numbers. We're looking at 6.022 times 10 to the 23rd. 1. This is still moles of lead, atoms of lead. What unit would we have now? Moles of lead. Is that the same thing as grams of lead? No. So what do we need to do? We want moles of lead on the bottom. We want grams of lead on top. Is there something that relates the moles and grams? The mass and moles? Our molar mass for lead is 207.2 grams per 1 mole of lead. We're following it up, pushing through all of the units. We can now enter it into the calculator, and we should end up with grams of lead. How did somebody get that 10 to the 47 number?
Because they combine. Oh wait, what?
It is a purely calculator-driven mistake. You didn't use parentheses around the 6.022 times 10 to the 23rd, which meant when you went through and did the calculation, you took 2.55 times 10 to the 23rd divided by 6.022, and then you said multiply, which meant that power of 10 went from being in the denominator to being in the numerator in the calculator. Your work is spot on. You're horrible with a calculator. Unfortunately, you're tested at both levels. Right? The calculator aspect is a skill that I expect you to know coming into the class. If you're making this mistake, what should you do? That's not very helpful. You're making a mistake. Stop making the mistake. I keep walking into the wall. Stop walking into the wall.
Learn the proper format.
That's pretty easy.
Learn to change your direction.
I just do everything on top.
What is changing the direction? If I keep walking into the wall, how do I know to not walk into the wall anymore?
Stop walking into the wall. Stop walking. Open your eyes. Turn around.
Go forward.
Open your eyes.
So good there's not really class.
Wait,
Put your hand out.
somebody's telling me that I should change my behavior by opening my eyes. Stop turning so much. What had to happen? You had to tell me that information. If you're walking into the wall by running these silly calculator mistakes, that's fine. Stop just running into the wall. Ask for help. Right? I'm trying to address this by pointing it out. That doesn't mean it's now going to be inherently obvious for you. Ask for that help, and we can work through it together to make sure you don't make that mistake in the future. But you have to be active in your learning process.
So the takeaway from this is to, let's see. Well, I just made myself embarrassing. I not remember
Nope.
what you just said. That's fantastic. Awesome.
There's two takeaways. Number one, follow the unit process that we've gone through and solved.
Right.
Dimensional analysis is there. The next part is you have to have calculator skills within this. If you are missing either of those, don't just keep pounding your head at this and hoping it just magically works. It won't. What do you need?
To ask questions?
You need to be asking questions and getting that extra help. Ask for it. That's the big lesson.
So understand the rules and ask questions.
And ask for help. Yes. Right. And because I need some help, solve this one. So let's go ahead and start. First thing I want to draw your attention to. I've boxed in two English textual terms. What are those two terms I boxed in?
Fluorine atoms and fluorine gas.
Fluorine atoms and fluorine gas. Notice I boxed them in different colors. Why might I box them in different colors? They are two different things. Fluorine atoms is what? Just F. Fluorine gas is F2. You have to be careful when going through to make sure that you're doing your nomenclature appropriately. How do we know fluorine gas is F2?
Diatomic.
It's a diatomic element. We had to have that memorized. Okay. How do I know that I can be looking at fluorine atoms as a single F? If it just says fluorine, it's F2. If it says fluorine atoms, you have to see that word atoms. If you don't see the word atoms, you're not looking at a single atom.
Sorry, you said because it's a diatomic element, that means what? You said?
Its default is F2.
Right.
That's how many
That's what they are.
So
Default needs to be paired. What's that?
So one more has to-
We'll come back to what that means later in our conversion. What are we trying to get to for an answer?
Atoms of fluorine gas.
Atoms of fluorine gas. What would our unit look like? Atoms is our measurement. The substance being just F. All right, what am I starting with?
2.25 grams.
Grams of
F2.
F2. What's the number? 2.25. over 1 mole. Does it say moles in 2.25? No. Don't start adding it in. The term it gave you was 2.25 grams, period. Okay. Take a look at your units. Grams and atoms. Do we have the same measurement?
No.
No. F2 and F. Do we have the same substance? No. Remember how we said we had to wait until chapter 9 to convert substances? I lied.
Oh, fantastic.
Formulas do the same thing. You can convert substances through a formula. Okay? So, we've got lots of conversions to go through and do. Which one do you want to start with? Substance or measurement? Okay, I heard a substance.
Measurement. Because she said substance.
Unacceptable. F2 would need to show up in the denominator. Why?
Because you're trying to cancel out.
I need that substance to cancel out. Okay, what should show up in the numerator?
2F.
What's the unit of the
F.
substance? Just F. Okay. Now what's the measurement? What's the unit that goes with those?
2F equals 1F.
Okay. 2 is not a unit. 2 is a number.
Oh, unit.
Okay. We could say moles of F, which then means the bottom one would also be moles. Okay. When I'm converting substances, I'm not changing the masses. I'm changing, it's the number of those atoms. There are 2 atoms of F in 1 molecule of F2. Notice I said atoms and molecules, and what's written there is moles. What? This is really 2 moles of what? Atoms of F. This is 1 mole of molecules of F2. Mole is a scalar factor. Because that mole is the same in both cases, it's effectively negated. And what we're left with would be molecules of F2 and atoms of F. Again, because moles are a scalar factor, I can include moles, I cannot include moles. Either is fine. That can't be true. Okay, make mole a number. 1,000, 1,000. What happens? Right? Because we said moles. You're saying I can't just get rid of moles, right? That doesn't make any sense. Okay, I'm saying that that is valid. If mole is 1,000, what happens?
It doesn't equal out.
It doesn't equal out? 1,000 does not cancel 1,000?
But it does with the 2 over 1.
Did the 2 over 1 cancel? Am I saying to get rid of the 2 over 1? No, I'm saying to get rid of the moles. Okay? So there are 2 conversions that allow me to relate fluorine atoms and fluorine molecules. I can relate it through the moles, and very typically when we write moles, we end up implying atoms and molecules. Or I can write atoms and molecules and just ignore the moles. Either is fine because they're getting at the same point. We're trying to convert the relationship. Where did I find that relationship?
With the substance.
Okay. That relationship came from the formula. If I look at F2, how many F's are in it?
2.
Make sense? Okay. So this was an interesting conversion to go through and do. Did that simplify the left-hand side of our equation at all? No. Is it wrong? No. I have F in the proper spot in the numerator, and I'm attempting to get rid of F2. Can I cancel molecules of F2 with grams of F2? No. Okay, so it's not an invalid conversion. It's just not doing anything for us right away. Okay?
Does it make a difference in your final answer?
Does not make a difference in your final answer. It's just a question of when you want to use it. Okay? So, what do you want to get rid of now?
Grams.
Okay, you want to get rid of grams. Grams of what?
Up to.
F2. Okay? I heard moles of F2. We did not get rid of F2. Notice there's no canceling at this stage in the game. Nothing has canceled. Okay? The conversion we did in purple from our formula doesn't cancel any units. No units disappear from our conversion because there's no matching units. Substances match, not units. So we are moving in the right direction. We just haven't done anything to cancel. Okay? The next suggestion was, okay, let's get rid of the grams to try and at least fix this gram issue. I can now convert those grams into pretty much anything I want. The suggestion was to take it to moles of F2. Okay? Could you convert it to something else? Can't go into moles of F, that's a different substance. You could go to AMUs. Okay? That's fair. Okay? I would make an argument that that's going to be a bit challenging, and I don't think I want to go there. Okay? But I could go through and do it. Where do I find the conversion factor between the moles of F2 and the grams of F2?
grams.
Gram is a measure of mass. Mass moles, mass moles, molar mass, which is found on the periodic table. No Avogadro's number. So I look up F and I find it's 19. Should I be writing 19 in there? Why not? There's two of them in our formula. So I should be writing 38 grams of F2 is 1 mole of F2. Grams of F2 now cancel. Okay. So we've now gotten rid of the mass unit. Okay. Am I at my final answer? No, I have molecules of F2 and I have moles of F2 that I don't want. Those units need to somehow disappear. Which unit do I want to try and get rid of first? Okay. I heard molecules of F2 first. Sorry for those of you saying moles. Molecules of F2 needs to show up in the numerator. Why?
Because you cancel it.
Because I'm trying to cancel it out over there, right? Everybody see that?
Yeah.
What can I convert molecules of F2 to? I could convert into atoms of F. What happens if I do that?
Then your F's cancel out.
Then your F's cancel out, and the unit we'd have at the end? No.
It's just atoms.
We'd have
Grams.
the grams of F2 canceled.
So you have moles.
You'd have moles of F2. Is that what you want for an answer? No. So while I can convert to atoms of F, that is perfectly valid. That doesn't do anything useful. Pick a different conversion factor. What was that, Ahmad? Maybe I want to convert those molecules of F2 to moles of molecules of F2, which would be Avogadro's number. 6.022 times 10 to the 23rd molecules of F2 is 1 mole of F2. That's great. Okay, so I like your suggestion because now my molecules of F2 cancel, right?
Is it molecules or atoms?
Okay. Is it molecules or is it atoms? I go into the store and buy a dozen. What am I buying? Say that again? 12 what?
12 eggs.
12 eggs. I go to the baker and I ask for a dozen. What does he give me?
12 donuts.
He's not giving me eggs. Does a dozen mean eggs?
It just means 12.
It just means 12.
Or a baker's dozen, isn't it? Like
Don't open that. Okay. What is a mole? A mole is a dozen. Okay. So that officially is actually a mole of molecules of F2 because I'm looking at molecules of F2.
But aren't you just creating a new unit then?
Am I creating a new unit? Well, take a look. Molecules of F2 cancel. And yes, damn it, I brought in moles of F2. What does that say?
But that's moles of F2, that's moles of molecules of F2.
What is F2?
Molecules.
A molecule. So a mole of F2 is really a mole of molecules of F2. Molecule is the descriptor of what that species is.
Yes.
What does that mean? That unit cancels. What unit are we left with?
Atoms. F.
Atoms of F. What are we trying to solve for?
Atoms.
Atoms of F. What did we just do?
Sulfur.
We solved it. Okay? So let's backtrack.
Let's do it.
Okay? No, we're going to backtrack for one important reason. Where I saw everybody freak out and get lost was with that 2 atoms of F and 1 molecule of F2. And I would agree with that statement. I think that is a rough conversion to do. Because what happened? You inserted a conversion factor that got rid of nothing.
And we try to cancel out.
Okay. Did it work?
No. Oh, it worked.
Yeah, it did eventually work. Okay? But it made things a lot more complex at first and then made you go, oh my God, I must have done something wrong. You didn't do anything wrong. You just inserted a conversion factor at the wrong time, okay, that confused you. That doesn't make it wrong. So let's go back through and let's fix this so that we don't incur that issue. 2.25 grams of F2.
I wonder who wanted substance first.
Yeah.
I was not going to do any bus throwing.
Bus throwing.
You have to describe it somehow.
I was like, how many moles is this substance?
Let's do the mass conversion first. Grams of F2 cancel, right?
Yeah.
So we've simplified our calculation, but we aren't at our answer of moles of F2. I need to get those, atoms of F. I need to get those moles of F2 converted into something. What do I want to convert them into? I heard a suggestion to go into moles of F. Okay. Is that a conversion factor I can do? Yeah. 2 moles of F are found in 1 mole of F2. What happens?
Cancel.
Those units cancel. I now have moles of F. What do I want?
Atoms.
How do I relate moles of F to atoms of F?
Avogadro.
That would be Avogadro's number, 6.022 times 10 to the 23rd. 1. What happens? Moles of F cancel. What do you have? Your atoms of F. Do you get to the exact same answer? Yes. Mathematically, is everything the same? Yes. The only thing that changes is the unit systems under which you did your conversions. Okay? This is one of the things that students find challenging with dimensional analysis. They'll watch someone solve, they go, oh, they got the right answer. I got to repeat that. Okay? But then something happens where they change the order and go, oh, now I can't solve it anymore. No. You can still solve it. Track your units. Make sure the units line up the way they're supposed to. Okay? Everything can change. Each of those locations is independent of every other. It's a question of lining them up and matching them. I still got 2 minutes, and since you're packing, I'm going to talk an extra 2 minutes. Right? We're lining this up and trying to run those conversions and set them out. Okay? When we go through and talk about it in class, because this is something that students tend to freak out at, what do I end up showing? I show you the wrong things. Because you will do the wrong thing on the test. If I only talk about the right thing, what happens? You're like, oh, I'm always right. No, you're not. Okay? And what will end up happening is on the test, you'll run under the assumption that you're always right, and you'll get everything wrong. By showing you the wrong thing and helping you to see where those mistakes happen, you should be able to recognize on the test and critique your own work. Much the same way that when you write a draft in English, what do you then have to go back and do? Revise it by going back and looking for all of your mistakes. If you don't see those mistakes, they never get fixed. You submit a document that then gets shredded and gets no points because you didn't do that revision process, because you aren't aware of what to look for as a failure.
Or in this instance, there wasn't anything wrong with the first way, right? But the
That's true.
structure of it wasn't streamlined, so someone coming in to read that wouldn't be able to go A to B, B to C, C to D, and track your logic in the first one. So you restructured the steps to make it clear to read and digest.
So we can cancel out anyway, too.
So if we looked at, say, sentence weaving through a paragraph, how do you move from point A to point B, okay, or point A to point F? You don't go point A to point C to point B to point F. Oh, I forgot D, I'm going to go back to D and then go to E. There's a complete loss of thought on what's happening there. All the information is presented. It's not necessarily presented in a way that a reader can follow. Okay? Kind of makes sense? Okay. So, real fast, you're going to walk me through this one. Yep, because I'm a horrible person. I accept it. What do we want for an answer? Grams of a single molecule of S2, right? Sulfur dioxide. We're told the molar mass of sulfur dioxide is grams per mole. Okay, right? So, 64.07 grams sulfur dioxide per 1 mole of sulfur dioxide. Do we want moles of sulfur dioxide? No, and this is right up Ahmad's alley because he keeps saying it. What can we do to convert moles of sulfur dioxide? We can convert those into molecules of sulfur dioxide using Avogadro's number, 6.022 times 10 to the 23rd. 1. What happens with our units? Moles of S2 cancel. I would now have the mass per molecules of SO2. What do I want?
So you gotta cancel out.
I need grams of SO2. How do I cancel molecules of SO2?
Would it be like the 1.66?
1.66 times 10 to the negative 24th. Awesome number. That's cool. I could also say 12.
No, I'm just kidding.
1.66 times 10 to the negative 24th. Grams is 1 AMU. Is grams or AMUs molecules of SO2? No. Okay, so spitting out numbers or jamming numbers in is the wrong way to go about this. I need that unit.
So would it be the mass?
How do I spell molecules of sulfur dioxide? I believe it starts with MOLECULE, right? And then SULFURDIOXID, right? And what I'm looking for is the number, say, in front of molecules of sulfur dioxide. What does single mean?
No, your grammar's wrong.
What happens? I get your answer. What goes in the denominator? 1. Anything other than 1, it's not a single molecule of SO2. Okay.
Wait, what's the point of doing that?
What's the point
Just to
of
cancel out the...
just to cancel out the unit? No, not just to cancel out the unit. To answer the question. What does the question ask for?
grams, a single molecule.
A single molecule. Why does it need to show up? Because that's what I'm asked to do. Solve for a single molecule. That molecule of SO2 has to cancel out. I need the numerical value to go with it. Okay? Why is this difficult? What did Mike just stealthily do within the question? You were looking for grams of SO2.
So you just said, okay,
I just used English
Yeah, you just changed English. No,
into a mathematical system. You have to be able to interpret back and forth.
What the heck?
And with that, we'll go ahead and